So now what we want to do is we want to take this flow of 9,413.8 cubic feet per second, and we want to plug it into a program called HEC-RAS, which stands for Hydrologic Engineering Center River Analysis System. And so the whole point of this is that it's going to give us how high the water reaches, or the water surface elevations, after we plug in the flows. So I can take that flow, I can come to the flow file here, do 9,413.8 mini refrigerators, right, cubic feet per second. I'm going to apply that data, save the flow data, and then close out of that. Now what's going on here is you see the geometry file. What I have done is ahead of time I have set up cross sections of this creek. So if I click through it, we can actually just walk down the creek bed, and there's not a lot of data points here, so you can tell that it's kind of rough, but you get the idea of where the low points are and where the water might flow. And you can see over here that we're just sort of moving downstream. Now I just drew in a line and put in these cross sections, so this isn't as pretty as it could look, but it still does the job. So I'm going to walk down the stream. These green lines, don't worry about them. That deals with ineffective flow, and it's a whole other set of calculations, but I had to put that in to make it realistic. Here we're at the bridge, and then there's actually a relief bridge over here, because when you got that much water flowing through this one spot, let me zoom in. When you've got that much water flowing through here, sometimes you need an area where it can spill over and continue to flow without overtopping the road. Okay, so let's go ahead and run those flows. So I just need to come here. It's going to need to compute. It's doing its thing. There we go. And I can come here. I need to turn on the water surface so that I can see that. And now I can see a water surface here and just how high up it's going to reach. At the top part of our creek, it reaches 466.5 feet, an elevation of 466.5 above sea level. And then you can see it just continues to drop, which makes sense. We're going downhill. 464.85, and then finally when we get to the bridge, you can see that it goes through both of these areas here, reaching an elevation of 463.59, which is well below the top of the road here, so we know that it would make it through safely. And then here's where this really gets interesting, is that I can actually come in and look at a three-dimensional view of what's going on with the creek, simply based off of those cross sections that I gave the software to begin with. So I can get a pretty good idea of what this is going to look like based on the data that I gave it in 2 dimensions, and I just gave it several 2-dimensional shapes, and it's telling me what's going on here. And then I can actually zoom in and get a pretty good look at what my bridge and road structure looks like there. Can see about where the water surface elevations are hitting. So it's a pretty powerful and efficient tool to work with.